Yesterday we had talked about dividing polynomials using long division or synthetic division, and then finding the zeros after doing long division or synthetic division, but we were given a 0 to test. What if we're not given a 0? If we're not given a 0, then we have to use the rational zero test. And what the rational zero test will do, it will tell us what the possible zeros are. And then we can use synthetic division with those possible zeros to narrow it down. So for the rational zero test, what we do is we do the factors of the constant term, so the number without an x or a variable attached to it, divided by the factors of the leading coefficient, so the number with the biggest exponent. Now it's important to note that it's plus or minus, so we would have to deal with the negative factors and the positive factors. Now, if you think about some of the problems that we've had recently, that would be a lot of zeros to guess, and some ways to narrow it down would be to look at your final row for synthetic division. So when you do synthetic division, we have a number here, and then we get our answer down here. And if we have all positive numbers as our synthetic division answer, so like we do our synthetic division and we have 1, 5, 7, 6, okay, since those are all positive numbers, we know that there are no numbers larger than that. So we can cross off quite a few of them. So I always like to start out with 1 or -1, because if I do encounter this, then I know I don't need to test anything larger than 1. If the final row has alternating signs, so again, we're doing our synthetic division, and we have like a 1, -4, +11, -8, we know that there's no zero smaller than that. So again, if I test 1 and I have alternating signs, then I don't have to test any negative numbers at all. I can just start testing positive ones. When we were talking about factors, we said if the last number was 0, then we had a factor, but if it's not 0, what that tells us is the value of the function at that point. So in this example here, we're dividing synthetically by 4, and we get a remainder of 3. So what that tells us is that f of 4 is equal to 3. So if I were to plug in 4 into that function, I would get 3 as my y value. Right, so to find real solutions, first we always want to factor if we can. GCFs, factor by grouping, quadratic form. Always do that first, because sometimes that makes life a heck of a lot easier. Then, if we still aren't able to find all the zeros, make a list of possible rational zeros, and then use synthetic division to find the rational zeros until we are left with a quadratic or something else that is factorable that we can deal with. So let's go to the next page. It says find all the real solutions for f of x equals 2x to the fourth plus 7x to the third minus 26x squared plus 23x minus 6. So first we're going to check factoring. We can't factor it, so we're going to list our possible zeros. So our possible zeros are plus or minus. The factors of 6 are 1, 2, 3, 6 over the factors of 2, 1, and 2. And it's plus or minus. So if we were to write them all out, okay, it's going to be all of these numbers over 1. So plus or minus 1 over 1, 2 over 1, 3 over 1, 6 over 1, and then all these numbers now over 2. So 1 over 2, 2 over 2, which is 1, so we don't need to write it again, 3 over 2, 6 over 2, which is 3. So we have plus or minus 1, 2, 3, 6, 1/2, and 3/2. So there's 10 possibilities that we could have. Now, when you're taking your test or quiz, if there's going to be 10 or 8 possible zeros or more, we're going to give you one of the zeros. But if there's only 4 or 6 possible zeros, you're going to have to do this rational zero test and guess and check which ones will work. Because if there's only 6 of them, and if it's a cubic or a fourth degree function, you know that 3 or 4 of them could work. All right, so we'll do synthetic division with, I always start with 1. We can do synthetic division with fractions, and we'll talk about that later on. So I'm going to try 1, and then 2, 7, negative 26, 23, negative 6. All right, so we bring down the 2. 2 times 1 is 1. 2 times 1 is 2. 7 plus 2 is 9. 9 times 1 is 9. Negative 26 plus 9 is negative 17. Negative 17 times 1 is negative 17. 23 plus negative 17 is 6. 6 times 1 is 6. So then we get 0. So x equals 1 is a solution. So that means if we were to write this in factored form, it'd be x minus 1, and then 2x to the third plus 9x squared minus 17x plus 6. And I'm writing this in factored form over here because if we can factor this now, we don't have to do any more synthetic division. But unfortunately, we can't, so we have to do synthetic division again. And I'm going to try it with 1/2 this time so that you can see how you would do synthetic division with a fraction. So now we're going to synthetically divide the 2x to the third plus 9x squared minus 17x plus 6. Bring down the 2. 2 times 1/2 is 1. 9 plus 1 is 10. 10 times 1/2 is 5. Negative 17 plus 5 is negative 12. And then negative 12 times 1/2 is 6. All right, so 1/2 was a solution. So now I'm going to come over here and write this as x minus 1 times x minus 1/2. And we're going to fix that in a minute. And then we have 2x squared plus 10x minus 12. So with that 2 right here, we notice that all of these values can be divided by 2, so we can factor out a 2. So x minus 1/2 times x minus 1 times x minus 1/2 times 2 times x squared plus 10x minus 1/2. I'm sorry, not 10x, 5x minus 6. So look at, we have a 2 that needs to be multiplied. We have this x minus 1/2, which we know we can't have a minus 1/2 inside our factored form. So I'm going to actually distribute this here because that will allow us to get rid of that fraction. So x minus 1 times 2x minus 1. And then we're going to factor this. 2 numbers that multiply to negative 6 but add to positive 5. That's x minus 6, so x plus 6, and x minus 1. Well, we already have an x minus 1 here. So our zeros, x equals 1, and then x equals 1/2, x equals 6. So those, we don't need to write the x equals +1 again because we already did that. So those are the 3 zeros. So we got lucky on this one that we were able to get these zeros quickly. All right, for this one we can't factor it. We look at that, there's no GCF to factor, so we're going to do the plus or minus factors of 18. So there's a lot of factors of 18. We have 1, 2, 3, 6, 9, 18 over the factors of 6. So there's quite a number of factors that we have. Okay. Then we can write it out, 1 over 1, so it's going to be plus or minus 1, plus or minus 1/2, plus or minus 1/3, plus or minus 1/6. Okay, then we have 2 over 1, so 2. 2 over 2, which is 1, so we don't need to write that, but then we have 2/3. 2 over 6, which reduces to 1/3, so we don't have to write that. Then we have 3 over 1, then 3 over 2. 3 over 3 we don't need to write. And then 3 over 6 reduces to 1/2. We don't have to write that either. So then we have 6. 6 over 2 is 3. We already got that. 6 over 3 is 2. We already have that. And 6 over 6 is 1. We already have that. So then we have 9 over 1. So just 9. 9 over 2. 9 over 3 is 3, and we already have that written down. 9 over 6 reduces down to 3/2. We already have that. And then we have 18 over 1. And then 18 over 2, we already have that as 9. 18 over 3 is 6. We already have that. And 18 over 6 is 3. We already have that. So we have all these zeros here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, but then also the negative one. So we have 24 possibilities. So on your homework or in situations where we have this many and you don't have a given zero, we're going to use our graphing calculator not to calculate the zeros because I still want to get you practice doing synthetic division, but this will narrow down which zeros we should test. Oops, we don't want that. We don't want all that. So 6x to the 4th power minus 25x to the 3rd plus 14x squared plus 27x minus 18. And then when we graph that, we're just going to look and see if this will help narrow things down. So based on this graph, it looks like -1 would be a 0, and maybe +3 would be a 0, and maybe one of these fractions would be 1. But I would rather do integers with synthetic division. All right, so now let's try -1, and then our 6. Let's try 3 first. So we have 6, -25, 14, 27, -18. Bring down the 6. 6 times 3 is 18. And add that, we get -7. 7 times 3 is -24. Add that, we get, whoops, not -24, -21. Add that, we get -7. -7 times 3 is -21. Then we get 6. 6 times 3 is 18. Okay, so 3 was a solution. So I'm going to write that over here. X minus 3 is a factor. And then we are going to do synthetic division with the rest. So let's try now -1. And then 6, -7, -7, and 6. So we'll bring down 6. 6 times -1 is -6. Those you get -13. -13 times -1 is +13. Add those together, you get positive 6. 6 times negative 1 is negative 6, which gets us 0. So negative 1 is a solution, so x minus 3, x plus 1, and then we are left with 6x squared minus 13x plus 6. So now we can factor, hopefully, this right here. And you can factor it, guess and check. You could factor it with grouping, whichever way is easier for you. So x minus 3 times x plus 1, and then 6x squared. We need two numbers that multiply to 36, but add to negative 13. That'd be negative 9 and negative 4. So then we have x minus 3 times x plus 1. And then we can factor out a 3x. And then we're left with 2x minus 3. Factor out a negative 2. And we're left with 2x minus 3. So then our final factored form is going to be this, which then makes our zeros x equals 3, x equals negative 1. We talked about this the other day. We can do, when we have that, we can do the opposite of this number divided by that. So x equals positive 2 over 3, and then x equals positive 3 over 2. So we had 4 zeros in that one, and we used the graphing calculator to narrow it down a bit. Now, example 3 says rewrite the following function in factored form. So I don't want the zeros, I want factored form. Can we factor this? Can we do grouping? No, we can't do grouping. So plus or minus are factors of the constant 6. So 1, 2, 3, 6. And then factors of 2, or just 1 and 2. So it's the same possibilities as the one on the first page. So we have 1 over 1, so plus or minus 1. 1 over 2, so 1/2. 2 over 1. 2 over 2 we don't need to write down. 3 over 1. 3 over 2 we'll write down. And then 6 over 1, write down. And then 6 over 2 is 3. So we have 12 possible zeros because we also have the negative 1. So we'll start with 1. And then our coefficients 2, 5, negative 1, and negative 6. So we'll bring down the 2. 2 times 1 is 2. 5 plus 2 is 7. 7 times 1 is 7. Negative 1 plus 7 is 6. 6 times 1 is 6, and then we get 0. So we have x minus 1 as a factor, and then 2x squared plus 7x plus 6. And we say, can we factor that? If we multiply 2 and 6, we get 12. Are there two numbers that multiply to 12 but add to 7? And that would be 4 and 3. So x minus 1. Then we have 2x squared plus 4x plus 3x plus 6. And then we can do our factor by grouping x minus 1. And then factor out a 2x. And we're left with x plus 2. Factor out a positive 3. And we're left with x plus 2. And then our final factored form will be x minus 1 times 2x plus 3 times x plus 2. And again, because it didn't say find the zeros, we're going to leave it just like that. All right, now example 4, what we have here is this function z to the third plus 11 over 6z squared minus 1/2 z minus 1/3. And then I wrote over here, well, if we factored out a 1/6, that would be like multiplying everything by 6. And you see that all of our coefficients are now nice integers instead of fractions that we have to deal with. So we can look and we can do stuff like that to make synthetic division easier. So we can't factor that, so let's do our possible zeros. So plus or minus factors of 2 are 1 and 2 over the factors of 6. Ooh, so I'm going to have a feeling that at least one of our zeros is going to be a fraction. So it could be plus or minus 1, plus or minus 1/2, plus or minus 1/3, 1/6, and then 2 over 1, 2 over 2 we don't need to write down. 2 over 3 is a possible zero, and 2 over 6 reduces to 1/3. So we have 12 possibilities. And normally I would maybe use the graphing calculator, but I want to show you something that I mentioned on the first page. Let's divide by 1. So we divide by 1, and our leading coefficients, we're going to use this one now. So 6, 11, -3, -2. Bring this down. 6 times 1 is 6. And when we add that, we get 17. 17 times 1 is 17. We add that, we get 14. 14 times 1 is 14. And we add that, we get 12. Okay, so 1 is not a 0, but since these are all positive, no 0 is larger than 1. So that means we don't have to try 2. So that saves us that work. And maybe for this one, yeah, okay, you just eliminated 1 0. But for example, like this one, if we eliminated 1, if 1 didn't work and it was eliminated, then we know we could have eliminated 2, 3, and 6. All right, so now let's try something slightly small. Let's try positive 1/2. So if we try positive 1/2, 6, 11, -3, -2. 6 times 1/2 is 3. 11 plus 3 is 14. 14 times 1/2 is 7. -3 plus 7 is 4. 4 times 1/2 is 2. Beautiful, we get 0. What do the directions say? Oh, find all the rational zeros. So we have x minus 1/2, and then we have 6x squared plus 14x plus 4. And now we want to factor this. Well, we can factor out a GCF of a 2, so that's going to make things a bit easier. So 3x squared plus 7x plus 2, because now this might be easier to do guess and check on because we don't have a lot of factors of 2 and 3. So I'm going to do guess and check for this one. And then we can multiply this by 2. So 2x minus 1. And then when I guess and check this, it's going to be 3x, and we know 1x. And because they're both plus and plus, my two parentheses are plus and plus, and then my factors of 2 are just 1 and 2. So the only real question is, does a 1 go there or does a 2 go there? And then when we guess and check, we have to make sure to get 7x. So it's going to go a 1 here and a 2, because when I multiply that out, I will get 7x. So then for our zeros, This one is going to be x equals positive 1/2. We already found that. This one's going to be x equals negative 1/3. And then this one's going to be x equals negative 2. So those would be our 3 zeros. All right, now this last problem on this page, we're not going to do it in class, but it's as if you want to see another example done. We're going to factor out in x. So when we factor out in x, we have 10x to the third minus 15x squared minus 16x plus 12. So this one is going to have a lot of factors. So many that I don't really want to write them down. Plus or minus factors of 12, 1, 2, 3, 4, 6, and 12, divided by the factors of 10, 1, 2, 5, 10. So yeah, that's going to be way too many to list out. So we're not going to. So the graphing calculator, I'm going to use this to narrow things down. So 10x to the third minus 15x squared minus 16x plus 12. And then we're going to graph. Okay, so it looks like negative 1 and positive 2 are solutions. So let's try positive 2. So we have 10, negative 15, negative 16, positive 12. 2 times 2, whoops, bring down the 10. 10 times 2 is 20. Negative 15 times plus 20 is 5. 5 times 2 is 10. Add that, we get negative 6. Okay, yep, so that does work. So x minus 2, and then we have 10x squared plus 5x minus 6. So now we look at this and see, can we factor that? And it turns out we can't factor that, so you'd have to use the quadratic formula. So x equals negative 5 plus or minus the square root of 5 squared minus 4 times a times c divided by 2 times 10. So in our calculator, I'm going to type in everything in that square root. So 5 squared minus 4, 5 squared minus 4 times 10 times negative 6, 265. So x equals negative 5 plus or minus the square root of 265 all over 20. Now 265, I'm going to see if I can divide that by a perfect square. So let's say 25. Nope, 265 divided by not 25. 125 is not a perfect square. So we may not be able to simplify the square root of 265. There's no perfect squares that can go into that. So then this would be our final answer. So we have the x equals negative 5 plus or minus square root of 265 over 20, and x equals 2 that we got from the original. So you won't see very many like this where you got to do the quadratic formula, but know that sometimes you may have to. So thanks for watching. Make sure to like the video and subscribe.